Welcome back, ladies and gentlemen. I'm sure our next topic has drawn some questionable look from some of our viewers. There is no such thing as artificial intelligence. What are your thoughts on this? Well, let us find out more. Without further ado, we'd like to call upon Dr. Luke Julia, co-creator, Siri, and Chief Scientific Officer, Renault Group USA, to take us through the actual AI journey. Over to you, Dr. Luke.
Hello, I'm Luke Julia. And I'm going to talk about artificial intelligence. I'm going to explain why there is no such thing actually as artificial intelligence. When I'm saying that there is no such thing as artificial intelligence, I'm talking about the artificial intelligence that the media are talking about for the past 5 years. This is what I call the Hollywood artificial intelligence, the science fiction. The one that is scary, the one that is maybe doing too many things, that we're expecting too many things from. So this is this artificial intelligence that doesn't exist. But what I'm going to try to explain today is what is the artificial intelligence that exists. And to do that, I'm going to go back to history, right? So actually, artificial intelligence is not from only 10, 20 years ago. It started way, way before that, because it really started in 1956. 1956 is when a bunch of scientists met in the Dartmouth University, and they decided to call what they were doing artificial intelligence, because they did model mathematically a neuron. And they said, if we have a neuron, we have a neural network. If we have a neural network, we have a brain. And if we have a brain, we now have artificial intelligence. And of course, I'm going to show you that they were wrong to call that like that, because the very first model of a neuron was very, very simple and couldn't match the complexity of our brain. But when you think about what they wanted to do, they wanted basically to create a robot of some sort that was going to perform some intellectual tasks, right? And so it wasn't new actually in 1956. And if you think about it, the humans did try that for centuries. And since I'm French, you know, I like to start the artificial intelligence history back actually in 1642. So what happened in 1642, there was a French mathematician and philosopher, Pascal, who invented the Pascaline. The Pascaline was the very first computer, basically the first calculator. It was a very simple one, you know, it was doing addition and subtractions, but actually it was doing them very, very well, because it was never making any mistake, right? So if I ask you right now, how much is 2338 plus 3629, I mean, you are going to spend some time, you know, to perform the task. And by the way, most likely you are going to be wrong. And the machine would have done that in less than 3-4 seconds, right? And again, it would have been right all the time, because it was a very simple mechanism after all. But it was, by the way, the very first calculator and the very first, you know, machine that for me is an intellectual machine. But frankly, I mean, if you dig into history a little bit more, you are going to find a lot of such machines, even no thousands years ago. So anyway, just to come back to our friends, you know, back in 1956, not only they mystically called what they were doing artificial intelligence, but they also basically failed in where they were trying to do. Because what they were trying to do was to try to solve what we call now natural language. And what is natural language is basically what we are doing right now. I mean, somebody is talking and somebody else is trying to understand what the person, you know, is talking about. So it's not only the words, it's also the meaning of the words. So, of course, you know, it's a very, very difficult task. And what happened, you know, in the 50s, they failed. I mean, they couldn't create a robot that could actually understand anything, by the way. So it's very, very sad, because this is what we call the very first winter of AI. right? So the winter of artificial intelligence. Why is it a winter? Because, I mean, since the science didn't perform as well as it was supposed to, and since they promised a lot of things that didn't happen, the funding, basically, was missing, and the domain basically died, and we entered what we call the winter of AI. And I'm afraid, actually, that there is a new winter of AI that will happen if we continue to talk about AI the wrong way, to give AI, too many power, or to say that it has too many power. We need to be very careful, because if we do that, I mean, the domain could die. And even though I'm saying that there is no artificial intelligence, there are actually many, many artificial intelligences, right? They are not doing as well as a human brain can do, but they are doing some very, very interesting tasks, as we are going to see it now. So anyway, so back in the 50s, they failed. And it was based mathematically on something that we are going to call the statistical AI, right? Statistical AI, because it was based on a neural network, and I will come back to that later. But in the 60s, 70s, another kind of AI, another kind of mathematical modeling came up, and it's called the logical AI. The logical side of it, it's what has been called since then the expert systems, right? So in the 70s, 80s, 90s, it was actually very popular because it was working pretty well. It was much simpler in the sense that it was based on rules. It was based on logical rules, and you could do something like if something happened, then do something, right? So it was something that was very well understood by a lot of people, and the machines were performing pretty well. And the proof of that is what happened in 1997, when such a machine, actually, that was called Deep Blue by IBM, beat the world champion Kasparov at chess. So it's very impressive, but actually I'm claiming there is no at all intelligence in this machine. What happened, in the 90s is that there were machines that had a lot of memories, so we could actually put a lot of those chess moves in the machine. In addition to that, we could actually have some CPUs that were performant enough to calculate the rules between the different moves, because chess is just a game with rules, right? So it matches very well this expert system method, and also chess is a finite game, in the sense that if you ask mathematicians how many moves there are at chess, they are going to tell you that there are about 10 to the power of 49 moves. So it's a lot of moves, but still you can calculate them, you can calculate between them. And what happened basically to Kasparov that very day, in 1997 when he lost, it was that the machine had basically every single move, that it can play, where Kasparov had maybe 10, 20 moves, that it could foresee. So he lost, and the machine, was actually deemed as an intelligent machine, but again, it wasn't that intelligent. But something else happened in the 90s. It was in 1994, 1993, 94, and it's the coming back of those neural networks. And you can ask, why did the winter of AI that we were talking about stopped, basically, and why did we see again, the neural networks that we called machine learning, and later deep learning, as we are going to see. And machine learning, this statistical AI, came back because of one thing that was very interesting in the 90s, and this one thing was internet. And internet came with a lot of data, right? And the big data is what is necessary for machine learning and deep learning. because the machine is going to need a lot of data for to create whatever we ask it, to recognize. By the way, the very first thing that was done in the 2000 years, is to have a machine that is going to recognize cats. So you can wonder, why do we want to recognize cats? I'm not sure about that, but what is sure is that back, in the 90s and the beginning of the internet, in the 2000 years, there were a lot of images of cats on the internet, right? And because people were posting, their cats, the images of their cats, and they were actually labeling, transcribing those images by saying, this is my cat, this is my kitty, this is whatever, right? So we ended up with a bunch, a lot of cats, and it was possible to create a machine that was going to recognize cats according to all the different cats, that were in this huge database of cats. But we needed basically to have about 100,000 cats to have a recognizer of cats that is going to be right 97% of the time. Right, so the accuracy was pretty high, but the number of cats, or of images of cats that was necessary, was very, very high. This is again what we call big data. And here, you can wonder about why do we need so many images of cats to create something that is accurate enough? And this is one of the issues, that I have about artificial intelligence, because actually it has nothing to do with intelligence. It has nothing to do with human intelligence. It has nothing to do with our brain. And why do I say that? Is because now we can ask how many cats the human need, to recognize cats, right? And not recognizing cats at 97%, but recognize cats all the time, every single time. And if you ask psychologists about that, they are going to tell you that my 2-year-old daughter, she only needs 2 instances of cats to recognize cats, all the time, even at night. When you think about it, the recognizer of cats that was done, the robot that was recognizing cats, it was actually not recognizing cats at night, because there is no picture of cats at night on the internet. It's not very interesting to do that. So the machine is not trained to recognize cats, at night. My daughter can recognize cats, even if it's night, because she has, with 2 instances of cats, the ability to have the best possible cat recognizer. So this is interesting, because again, this is proving that the techniques that are being used by this, deep learning or machine learning, they have nothing to do with our brain, and they have nothing to do with our intelligence. Another proof of that is coming about 10 years later, when this is the world champion of Go, who is beaten by the machine, right? The machine is called DeepMind. This is done not by IBM this time, but it's done by a company of Google, basically. And DeepMind is actually going to beat, this world champion of Go, which is very impressive, because Go is much more difficult to understand than chess. And if you ask mathematicians, by the way, they are going to tell you that at Go, there are about between 10 of the power of 200 and 10 of the power of 600 possible moves. Basically what it means is that those mathematicians, and nobody knows exactly how many moves there are at Go. And this is for us basically infinity. There are a lot. There are so many moves that we cannot, really have them all. And what it means that we cannot use expert systems like we were using for chess this time, but we are going to have to have a mix of rules, of course, because it's a game, but also a mix of statistical games. So the machines took about 30,000 games and did learn the rules from there, and was able after that to play, millions and millions of games, and able to beat the world champion. I'm not going to go into the algorithm themselves, but I'm going to look at the machine. And this machine, DeepMind, was actually, a big machine. It had about 1,500 CPUs. The CPUs are the chips inside the computers, basically. And so 1,500 CPUs. It had about 300 GPUs. GPUs are another kind of chips that allow you to display. This is a graphical processing unit. So it's very good at matricial calculation, which is very important in deep learning. And it had another kind of chips, yet another kind that was called TPUs. And the TPUs are specifically made by Google for this machine to do specifically deep learning. It has the algorithms, optimized for that. So anyway, so all that to say that this machine was a huge machine with about 2,000 chips in it, right? So 2,000 chips, I mean, it's basically, 2,000 computers, and it's, a small data center. And when you think about it, I mean, now you have this machine that is, 2,000 computers that is playing against the human. And the question is going to be, I mean, how much energy this machine is deploying in order to play Go, versus what the human in front of it is using. And there we are going to see that the machine is about 440 kilowatts. I mean, 440 kilowatts to play Go. And just to play Go, by the way, the machine is not able to do anything else, right? And in front of it, it has this Korean player, in this case, the world champion, who has only his brain to play, right? And this brain is about 20 watts, 20,000 times less, than the machine. What I'm saying here is that, I mean, you need to use a lot of energy in order to match something that the human can do. And by the way, it matches only one thing that the human can do, right? So we are deploying those machines using deep learning and machine learning, using big data that are using a huge amount of energy compared to our brain that is using only 20 watts. And by the way, our brain is able to do something else than playing Go in this case. I mean, this guy was able to talk, remember? I mean, it's very difficult to do, and was able to, cook and to do anything, right? And this is, again, a proof that those machines that we are creating have nothing to do with our brain and has nothing to do with intelligence. They are robots. They are mechanical machines doing only one kind of thing. A thing that we talked a lot about, is data, right? We need a lot of data in order to have those machines performing machine learning or deep learning. Deep learning is yet another statistical method that is using even more data, right? And of course, you know that for the statistic to be relevant, you need a lot of this data in order to have, as many samples as you can. But when you look at the data, I mean, data is dangerous to manipulate because, I mean, by definition, the data is historical data, and the historical data can be wrong in the sense that in today's society, it's very possible that we don't think the same way that we were thinking, decades ago. And one example of that came in 2016 as well, when Microsoft decided to put on Twitter a chatbot that was going to just promote, the Microsoft products. And the chatbot that was called Tai became actually the most racist and sexist chatbot in the history of chatbot. I mean, the history of chatbot wasn't very long, but I mean, still, it became basically to insult all the Black people and women, right? So, of course, this is not what Microsoft wanted, and they had to unplug this chatbot after only 16 hours of operation. I mean, and there you can wonder, but what happened? I mean, it doesn't make any sense that you are spending all this time, that you are using all this money, all this energy, all this data in order to create something that you need to unplug after 16 hours of operation. And you can look a little bit at what happens, right? And you can imagine that two kinds of bugs are possible, and two kinds of bugs can have, generate such a racist and sexist chatbot. First one is going to be what I'm going to call a classic bug, right? And when you create a chatbot, you want it to be well integrated in the assistants that it's going to talk to, right? It happens in this case that this chatbot was meant to be on Twitter, and it was something that was going to try to talk the same language of what the Twitter people are talking. And the way you do that, you have a slider basically that you call a adaptability slider that is going to adapt to the people you are talking to. And I think that it's possible that the slider was a little bit too high. And since, I mean, you may know that on Twitter, people, like to insult each other after 2 or 3 interactions. I mean, in this case, if the slider, was too high, I mean, it did insult people, very easily. So that is pretty easy to fix because you just, lower the slider, and lowering the slider basically means that you are going to control the conversation, right? You are going to control the way the chatbot is going to talk. So that could have been that, but I mean, it would have been easy to fix. So I don't think it was actually the issue. Another kind of bug can be what I'm going to call a data bug, right? A bug that is coming from the wrong data. In this case, I mean, this chatbot is on Twitter and is a conversational chatbot, right? And it's very actually difficult to find conversation because you need to train this chatbot on conversation, right? And it's very difficult to find conversation if the data is coming, from the web. I mean, that on the web you can find a lot of cats, but it's very difficult to find conversations. So, but it happens that since the 50s, so a very long time, there is a very big database that is called Switchboard, that is a database of annotated conversations, right? It's basically annotated conversations of people that are calling their call centers and complaining about their washing machine, their whatever, right? So this is existing, and there are actually millions of conversations that are being transcribed, and that is possible to use when you create some such system, like a chatbot. But the issue is that it's so big that most likely, the engineers that are going to create a chatbot, they are going to only take a subset of this big database. And here you can imagine, I mean, you have this big database, and you are going to say, okay, I'm going to take only a piece of it, and I'm going to take the 50s. I'm going to start, with the start of the alphabet. It's in the US. I'm going to take Alabama. And of course, if you think about it, if you took the conversation in the 50s from people in Alabama, you know that interestingly, the database can be racist, right? So, and it doesn't take a lot of time because on Twitter, people, are very crude, I would say. It didn't take a lot of time for the chatbot to become racist because it was, ingrained in the database itself. So what it means is that when you create such systems that are based on this huge amount of data, you need to be very, very careful in the way you choose the data. There are some other examples, that have been seen recently where a credit card company was giving half the credit to women compared to men for the exact same situation, same salary, same everything. And it happened that, this is the way it is actually in history. In history, women, got only, less than men. And so it happened that the robot that was distributing the credits for this credit card was just saying, okay, I mean, I know that from history, this is half, for women. So again, we need to be very, very careful to choose the data. And sometimes, when this data is biased, because, this is what it is, the data is biased, you need to remove the bias. The thing is that as soon as you try to remove the bias, it means that you enter your own bias in this database. And this is where the ethics are very, very important, because if you start to manipulate the data, if you start to change the data, if you start to balance the data, I mean, you start to put your own view of the world in the data and the view you think the data should be, right? And this is again where ethics is very important, because I mean you need to have your own ethics that is going to allow you to say that you were right in what you are doing, but also there should be some kind of ethics at the company level, the company that you are working for, to create such robots that are going to use the data that is manipulated, basically. And at the end of the day, I mean, I think that it should be the society that decides how and what data to use when you create such systems that are using such amount of data. And when I say that people should be saying how to use it, I'm of course talking about regulation. So we need, at the end of the day, to have regulation in the country, regulation in the continent, regulation in the world, in order to decide what are the systems, to collectively decide what are the systems that are reasonable and what are the systems that are good, and the kind of data that we can use. Of course, it's very complicated, and it means that people need to be educated. They need to understand how the system work in order to do such a thing. So that's something that we need to think about. And I think that at the end of the day, we really need to talk about regulation. Another aspect that is going to need regulation is that it's very, very complicated, right? So the algorithms are very complicated, and we always or often talk about artificial intelligence by saying that it's a black box, right? So saying that it's a black box, what does that mean? I mean, it means that we don't understand what is happening inside, right? And so if we don't understand what is happening inside, we're not going to trust it. We're going to be defiant, about it. So, but what I'm going to explain right here is that actually there is no inexplicability. So this is always explainable, right? So it shouldn't be a black box. It is a black box for most of the people who are creating those AIs, who are choosing the data, who are choosing the algorithm. They are able to explain what they are doing. They're able to explain what data they are using and what algorithm they are using and why. Of course, there can be bugs. We saw that before. There can be bugs in the algorithms. There can be bugs in the data. But I mean, the bottom line is that people who know can explain, and so for them, it's not a black box, but it's a black box for most of the people. And for that, I'm going to tell you a story, because it's not new. I mean, it has been true for the past centuries, for any science. Anything that is complicated, people are going to think that it's a black box. And the story I'm going to tell you is a story of a mathematician that in 1914, actually, discovered the fractals. If you don't know what fractals are, that's fine. I'm going to tell you a bit later, but you should look on Wikipedia, what is a fractal. But the fractal in 1914 was just a mathematical equation. It was a logarithm, and when you see it, I mean, most people, when they see this equation, they're not very excited about it. But the mathematicians, when they look at the equation, they immediately understand the property of this equation and why it's something incredible. I'm going to come to that. But I'm going to come to that only 40 years later, because this is in 1955 that somebody called Mandelbrot was a student of Julia, this mathematician, and he was a student of Julia at Polytechnic in France, a school in France, and he listened very, very well. He understood what this equation was and the property that was incredible, and he flew to the US, right? And in the US, he was given a computer, right? And it was one of the first computers. He entered the Julia set, the equation, he entered it. And of course, he renamed it to Mandelbrot set. I mean, why not? But anyway, so he renamed it like that. And entering the equation, he did plot, this thing on the screen, and appeared a beautiful drawing that explains with this simple drawing what is the property of this equation. And the drawing is basically a beautiful leaf that is showing another leaf inside, another leaf inside, another leaf inside, and it's always the same leaf. And this is very impressive. When you look at it, you immediately understand the property that is called recursivity. You understand immediately that you can have something that any level of recursivity is going to give the exact same result. And this is exactly what a fractal is. And what was totally unexplainable, before, inexplicable, becomes, with this simple drawing, something totally obvious to everybody, right? So I'm not saying that in 40 years, all the AI black boxes will become, obvious to everybody. But I'm saying that a lot of people are working on this explainability and are going to use most likely AI itself in order to be able to follow, the number of calculation, to follow the huge amount of data and to understand the path, and that are going to be able to explain to most of the people, how this thing is working. So most likely at one point, the black box will just, disappear, like, the fractal black box disappeared 40 years later in 1955. Another thing that is very interesting that I want to talk about is autonomous cars. I mean, autonomous cars, it's maybe, the dream that people have that is really the incarnation of AI, right? So when they talk about autonomous cars, they talk actually about those cars that could drive anywhere, anytime, without anybody, touching the wheel. And this kind of autonomous cars, we call that autonomous car level 5, right? This is the ultimate level. This is the ultimate autonomous cars. Back in 2018, at CES, the big show in Las Vegas, people were saying, oh yeah, autonomous cars level 5, they are coming very fast. It's going to happen in 5 years, right? And all people were excited and something. So anyway, in 2019, at the same show, people were a little bit less, excited about it, and say, yeah, it's coming, level 5 is coming, and it's going to happen in 10, 15 years. In 2020, even less excited. Yeah, it's coming, but it's difficult. I mean, it may come, in 20, 30 years. And 2021, I mean, the CES wasn't exactly the same way, but there were not a lot of people claiming that it could happen at all. Or happen very, very, very far in the time. And since the beginning, I'm saying that autonomous cars, level 5, will never happen. Not tomorrow, not in 5 years, not in 30 years, absolutely never. There will always be a case that is going to be a case that the computer doesn't have in its database, right? Never saw this case before in the history, or it's going always to be a case that there is no rule for it. Remember that in the expert systems kind of rules. And for that, I'm going to prove it. I mean, I'm going to make you understand, that it's never going to happen by giving you some very simple examples. The first one is a very good example for people who have been in Paris and know what's called the Place de l'Étoile, which is a huge square at the top of the Champs-Élysées, where it's a mess. It's a big mess of cars at 6 p.m., right? And there, if you just, put a car level 5 at the beginning of one of those huge avenues in Place de l'Étoile, I mean, the car will never move. Why? Because actually what is happening, at 6 p.m. on Place de l'Étoile is not normal driving. It's not something that you need to follow the rules of driving, what you learned, at school. You need to break them all, basically, because you need to push a little bit the guy, that is next to you. I mean, you need to negotiate a little bit. I mean, you need to do a lot of things that are very different from what you learned and from what the rules, are about. And so if you do that, you could maybe, create a car. You are going to spend a lot of time to understand the quote unquote rules that are happening in Paris. But I mean, most of the time you are going to spend a lot of time, but it's still going to be good enough. But then you take this car that succeeds maybe to cross this square, in 10, 20 minutes, but you take it and you bring it to Bangalore this time, right? And you most likely know that the traffic in Bangalore, I mean, this is just out of your mind, right? I mean, it's just incredible. And so this car, again, is not going to be able to do anything because there is no rule. But for that, there is even a better example than that is coming from Wemo. Wemo is a company from Google, and the CEO of Wemo back in 2018 actually said also that it's going to be very, very difficult to have level 5 or autonomous cars. And for that, he actually released all the videos that Wemo is recording in their cars. At the time, it was about 10 million miles of video that were taken, and he released that in saying, okay, now, I give all the data that I have, and you can, go and work on it, but most likely we will succeed to go to level 4, but we will never succeed to go to level 5. And by the way, level 4 is incredible. Level 4 would be something fantastic in the sense that it's going to most likely prevent 90% of the accidents. Most likely is going to help, to prevent a lot of death on the road. There will be accidents, there will be death, but much less, that what it is now. So we should go towards level 4 and basically forget level 5. I'm going to tell you why again later, but go to level 4, it will be incredible. Today, to give you an idea, the cars are about level 2.5, right? The best car in the research centers is most likely the Wemo cars that I was talking about. And they are, 2.5, 2.7. I mean, the Tesla cars that are maybe the best one on the commercial level, they are maybe at 2.5, despite what the CEO Elon Musk is saying. But anyway, so we are very far. But going to level 4 will be fantastic, but level 5 is very, very complicated. And so when the CEO of Wemo released those videos, 10 million miles of videos, it's a lot of videos. A lot of people went to start to watch those videos and to look at them. And I was, of course, one of them. And it didn't take a lot of time for me to find what I call a gem. What is going to be a gem in this case? It's a video that is going to show that the very case that we are seeing right now on the video is going just to be impossible to handle by a car. So let me describe it. So this is basically a car in Mountain View, it's just driving in Mountain View, and there is nothing happening on one of the streets there. And in the middle of nowhere, for no reason, the car stops, right? And the car stops for 2 or 3 seconds and then, starts again for a few meters and stops and start again and stop and start again and stop. And you see that for, about 2, 3 times, 4, 5 times. And then you realize that the operator takes the wheel back, and drives away because the people behind, they were most likely, surprised of the behavior of the car. But here, I mean, you're saying, what happened? I mean, it doesn't make any sense. And you watch the video a little bit closer, and you are going to look actually at the side of the road, and on the sidewalk, there are 2 people walking, right? So it doesn't matter that much. But actually, if you look very closely, you are going to see that one of the 2 guys that is walking, in the same direction of the car, on his shoulder, he carries a stop sign, right? Of course, if you see a guy carrying a stop sign on the side of the road, walking towards the same direction that you are, you don't care. You're just going to continue driving. But the car sees a stop sign and sees a stop sign and sees a stop sign, right? So this is the kind of case that is just, impossible to prevent. I mean, this is something that you cannot think about, that you don't have in the database, and that you cannot, have the rule for. I mean, unless you thought about those cases that are totally, unrealistic, right? So this is the reason for which those cars, the level 5 cars, they will never exist. Level 4, again, are going to help you to drive without touching the wheel most of the time. I mean, most of the time you are going to be able, the car is going to be able to drive by itself. When I say most of the time, it's going to be 99 point something, time. I mean, it's going to be pretty much all the time, but there will be always a case that is not possible. And you want maybe to have to touch the wheel yourself in this car. Maybe this car will be remotely controlled, right? And this is the person that is going to remotely control the car that is going to be able to handle it, right? So level 4 will be extraordinary to be already very, very good. So let's go towards that, and let's forget level 5. That doesn't make any sense. I mean, the thing that I'm saying here is that we should be careful, in the way we are using the technology, and we should think about how to use it correctly, and not to push and to have, the ideal vision of the time. And this is exactly what happened, with us when we created Siri back, in 1997. Actually, I mean, we were not the best at Siri, and we were not the best at speech recognition, basically. I mean, actually, the speech recognition was pretty bad, right? I mean, it was maybe right at 80% of the time or something. And it's because we knew that it was not very good that we added something on top of Siri that I call the stupidity, the artificial stupidity, actually. And what is artificial stupidity? It's something when the system doesn't understand what you are saying, it's going to tell you a joke. It's going to act a little bit stupid, right? And this is this humanization of Siri that did make its success. 13 years later, when Apple bought it and when it was released on the iPhone. And this is exactly what I'm saying here: is that the technology wasn't very, very good, but we found a way to humanize it, to put so the joke and to do that in order to make it more friendly, basically, something less like a robot. It is actually our mistake, in the sense that this is because of this kind of thing that a movie like Her, the Hollywood movie Her, was released, and Her makes think people that it can be something, an assistant that is going to do everything all the time with you, and you can even fall in love with her. So that's a mistake that we should have explained more, that this intelligence that we created wasn't actually very intelligent, right? And it has nothing to do with her. It has nothing to do with the kind of movie that is going to be those Hollywood movie. So what I want to finish with is basically to explain again that those machines that we are creating, they are not at all intelligent. We should have called that something else. And when I say that we should have called that something else, I mean, we can keep the AI letters, right? But I like to call that augmented intelligence. So why is it augmented intelligence? Because this intelligence, those intelligences, they are actually tools that are helping us to become a little bit more intelligent, to be a little bit, performant, a little bit better in what we are doing. And this is exactly what happened, back in 1642, when Pascal, released the calculator. It was just helping us to do those calculations, better. After all, it's not very interesting to do those additions and subtractions, right? So we can mechanize it and create them, have them, done for us, and spend the time doing something else. And this is exactly what this, artificial intelligence is. Artificial intelligence is a set of tools. It's a toolbox with a lot of different tools that are not working all together, because they cannot know what, the car is doing when the fridge is doing something. So we are the only beings that are able to do something like that. But every single of those intelligences, so every single tool, that is in this toolbox is going to be very, very good. And it's going to be better than us. And this is what is very interesting and what we have to understand. I mean, I like to compare one of those tools to a hammer. A hammer is actually very good at what it's supposed to do, right? I mean, when you use a hammer to drive a nail, it's going to, drive the nail very efficiently, much more efficiently than what your fist would have done. So you can use the hammer correctly, but you can also use the hammer, the wrong way. You can actually use the hammer to hit the head of your neighbor. And it's not good. I mean, it's not what it's supposed to be, and it hurts. But I mean, the thing there, what I'm saying is that you have the handle. You have the handle. You decide, you being us, us, the society, we decide how to use those tools, because we have the handle in our hands, right? So we can use them correctly, or we can use them the wrong way. And this is exactly what we need to think about when we are creating, all those tools, when we are creating all those artificial intelligences. We need to understand that they can be used the wrong way. They can have the wrong data. We saw that. They can use, too much power. So we have the keys. We have the handle, right? So we can decide how to use them. And to decide how to use them, we need, first of all, to understand everything that I talked about today, to understand the data that is used, to understand that it can be biased, to understand that it uses a lot of power, right? And collectively, we are going to regulate, to set a regulation that is going to tell, yes, you can do this kind of AI, but maybe you cannot do this kind of AI because it's going too much energy for what it's doing. So again, collectively, we will need to have all the keys to understand all that and to create this augmented intelligence where this is our intelligence that is augmented and not, the artificial intelligence that doesn't mean anything. And that is just, again, this toolbox of a huge amount of tools that are very efficient, very good, but that we control. With that, thank you very much. And I hope that you...
Thank you very much, Dr. Luc Julia. Now, that was absolutely mesmerizing, captivating, the way you took us on that uncertain AI journey and truly opening our eyes towards distinguishing between artificial intelligence as we see in Hollywood movies, as you say, those are just fiction and stories, as compared to what is happening in the real world today. So thank you very much for sharing with us your thoughts and your experiences, despite the time difference as we can see in the US. Now we will be moving along to our final session for this Anchor event. We surely hope that you'll join us. But first, do complete the survey for this session before moving on to our final one. Thank you very much, and we'll see you soon.